Hello, everybody, and welcome to SQL Friday number 63. Today we have Erland Sommarskog, who is, I was going to say you are the MVP with the most number of years that I know, but I also know T-ball. So unfortunately, you're not.
Yes, I will always be number 2 behind T-ball. No way around that.
That's just how it is. Anyway, I'm very happy to have you back on SQL Friday, Erland.
Yeah.
I will let you do the introduction of yourself and your presentation on your own.
Okay, so let's see. I go on and there's the share screen, desktop, and we should get rid of. I should just try to get the mouse over to the screen where I have the laptop. That's always
a good thing. Yes.
Yes, and the Teams thing automatically went out of the way. Yes, because I'm presenting off a VM, so that screen is now behind on the physical machine. Okay, so welcome to this presentation entitled Dynamic Search Conditions. So yes, my name is, as my name said, Erland Sommarskog, and I live here in Stockholm, work as an independent consultant, and I've been MVP for, yes, over 20 years, but I'm still a junior if you compare to Timo Karasi, which I believe is the MVP, MVP who has been in service for the longest period of time. And I have a website, sommarskog.se, which you can see as a small collection of larger articles that goes in depth in a couple of topics. And one of these articles is called Dynamic Search Conditions, and this presentation is actually called from that article. Here's my email address, sk.sommarskog.se. So if there are any questions, if you have any questions during the presentation, just drop them in the chat and Magnus will interrupt me. But if there anything comes to you after the presentation and you think, but what do you mean by that? Feel free just to drop me a line. I'd like to point out that you'll find slides and scripts for this presentation. They are on my website, sommarskog.se/present. So if there's anything you felt if I move on too fast and you want to take a photo, don't worry, you can just go and download the things there. So what is this all about? So in many databases, the users want to be able to search the data. Let's say we have an order database. So they want to find orders based on, well, of course, the order ID, but it could also be a date interval. It could be, well, some certain product on the order, or the certain customer, or the city the customer comes from, or the customer's shoe sizes, you name it. And of course, they want correct results for the searches. But not only that, these pesky users also insist of having good performance from, well, basically any condition they throw in. And that is the challenge we're going to tackle today. We're going to work in a database called Northgale, which has 1 million orders. This is an inflated version of the old demo database from Microsoft called Northwind, which had 830 orders. Now, that would be just way too small to show performance issues. Now, 1 million orders is big enough to show that something doesn't work, but a real production database could have 100 million orders. So we need to keep that in mind. Now, there's 2 ways to go to do these searches. We can use static SQL and we can use dynamic SQL. And it's very interesting. They actually are not in competition with each other, but they supplement each other very well, because when the one is strong, the other one is bad, it's not so good, and vice versa. And the way it works is simply the matter of complexity. So if the problem is just a matter of lots of different search conditions, but all in the same way, static SQL will be the easiest way to go. However, when you try, things get a little more complicated. You have to think about this and this and that. Well, then the complexity sort of grows exponentially. Whereas dynamic SQL, you start on a fairly high level from the start, but then the complexity grows more sort of linearly if you have to add more things to it. And you're going to see this during this presentation. And I will start with being static and then go dynamic. So first of all, this is the search problem we're going to tackle today. So let's see. There is my mouse. Sorry, so here I got a select list with all the columns, and then I have a join condition here. So let's see. Where is my, sorry, this is the thing, I have having 2 screens. Our mouse tends to get the focus onto the other screen. That's not so good. Let's see. Oh, let's see. Sorry about this, folks. No. Hopefully this is going to be all right. Okay, so I have an orders table, and I should join to an order details table, and then I join that to a customers table and a products table. And that spans space of order lines. Now, for a real order search, if you, let's say I'm searching for a product ID, I might want to see the full order, but we're going to keep things simple. So we're simply going to search for order lines to focus on the main thing, main problem. So, and these are the parameters we're going to expose to the users. So they can search for an order ID. You can search for an order ID, and you can, of course, that's the primary key of the orders table. You can search on the status of an order, and an order can be new, it can be P for processing, E for error, or C for completed. Now, over 99% of the orders have the value C. So therefore, there is an index on the status column, but it's a filtered index because there's absolutely no point in all of indexing the value C. And then you can search on the order date, and then that can be a date interval or as the open interval. So you can give a from date and a to date. And of course, the order date column is indexed. Then you can search on the custom ID. And yes, it's NCAR5. That comes from Northwind. I don't know why, but it's NCAR5. Very funny. And of course, there's an index on the custom ID column. Then we can also search on the customer name. And here it's well, if you enter BLA, that's it starts with. So it can be both Black and Blake. And there's an index on the customer name column as well in the customers table. And we can also search for the city or the region of the customer and the product ID, which is in the order details table. And of course, there's an index on that one as well. And finally, also the product name starts with. So now let's move over to do this search with static SQL. Here's the general pattern for the logic. So we say if order ID, and where is I'm sorry, my mouse, for some reason, it tends to escape and leave the laptop screen and went down to the other screen. Might be my fault in the end, but nevertheless. Sorry about that, folks. So we can say order ID equals at order ID, or at order ID is null, or status equal at status, or status is null, order date greater equal from date, or from date is null, or custom name like custom plus percent for starting with, or custom is null. Now, let's say we take a practical example. So we're going to search for orders that, well, from earlier this week for customers that are in Stockholm. So, because already is null, well then we, of course, this condition is true, and then status is null, well then this condition is true, and then we all just goes on like this. So we only have these left, and then from date is not null, so then and the state is not null. So these are basically what we have left: order date and from date. So order date greater than from date, or city equals at city. Now that's the logic of the whole thing. But now let's think about performance. So let's test this. And so we're going to first here. Well, let's see here now. All of a sudden, that one appeared on the scene. Going to get Magnus out of the way. So here I got this static search one. So here are the parameters that I mentioned before. Here's the select list, and here are the join conditions. Here are all the where conditions that are listed. And as I did mention, but that is also token order by to get a list of the orders, or to get the orders sorted in some order. I'm going to start with running just a quick search here on order ID to get something into the cache, and you can see that was fairly quick. Now I'm going to do 3 searches: one on order ID, one on new orders, and one for a specific product. And I'm also going to take how long time does it take. So I'm going to capture here in this variable the value of system time, and afterwards I'm going to print out the difference. How long time did it take? So let's try these. And this one was, as I said, was quick, 62 milliseconds. This one is 2.5 seconds. That's a little tad long for the users. They're not really going to like that. And this search on product ID, it's, well, yes, it's taking way too much time. So this, we can already now say this is not the final solution. We need to tweak this a little more. Yes, 20 seconds is just way too long. Although we've seen this, I'm going to do now. I'm going to force a recompile of the procedure, and then I'm going to do a search on product ID again. And now you can see that one was quick. But let's now run all these searches again. And well, previously the search on order ID was quick, but it is not anymore. It's now very slow. It's way too slow. So why does this happen? Well, this is a stop procedure. This is a single static query. It has one. So what happens is that when we run this stop procedure, SQL Server will build a query plan for the procedure and reuse that on every other invocation. So it's the same plan every time. Now, which plan you get depends on what parameter you actually pass the first time, because SQL Server sniffs the input parameters and, oh, I got an order ID. Okay, I'm going to optimize the plan for an order ID, but it still corrects for any other value, which means that, okay, the plan is quick for an order ID, but it's just way too slow for the other one. So we can see here that it's just, well, this one was okay, but these two are way too slow. So, but this is not what we wanted, because we have indexes in basically all these columns, and we want the appropriate index to be used depending on what search values we put in. So that's the first observation. We need different plans for different search conditions. So that is what we're going to aim at. I'm just repeating here on the slide what I just said. But before we go to look into that, I need to cover this because this is a trap you can run into. Every once in a while, when this comes up in forums, some people say, oh, do this instead. This is faster. So the pattern here instead is of doing the thing with or. They say, oh, order ID equal is null, order at order ID, o, order ID. So if this one is null, well, that's the thinking. Well, you have order ID equals order ID. Yeah. So this, of course, also going to give the same thing logically. It may seem, but let's have a look at this. So I got this procedure here, static search 2, and I've changed all the condition to this is null pattern. And I got one search here on order ID. Let's run this and we run into a snag. We get the wrong results. We don't get any rows back. We know that from the previous search that there is an order with order 11,000. So what is the problem? Well, the problem is here, the region column. That column is null. So let's go back and look here. What does this one say? Well, it says, oh, this one is null. So we have null and null. Now, in SQL, null stands for an unknown value, and we have this 3-value logic. So all comparisons with null yields unknown, because if we're comparing, well, city to null, well, that null could be the same value as city, or maybe not. We don't know. Well, in this, of course, it has to be the same unknown value because it's the same column, but there is no special room for that. So the outcome of this comparison is unknown, and therefore this row is filtered out. So this is a trap, and do not use this pattern. And no, it does not run faster because it has exactly the same problem. It's one single cached query plan. Now, let's now try to get different plans for different search conditions. So we can do this. We can say create procedure with recompile and compile the procedure to tell SQL Server, compile the procedure every time. This sounds like something that could work. So let's try this. So now it says with recompile here, and I've gone back to this pattern with or. So I'm going to create this guy, and then I'm going to run these things again. And it's definitely faster. This is definitely faster. This is definitely okay for the users. Everything is below 1 second is basically okay. But as I said, this is still a small test database, only 1 million orders. The full production database might have 100-fold volume. So can we get any idea of whether this will actually work in practice or not? Well, we could look at the execution plans. So let's try and look at this plan. And let's see how it looks like. And let's see what we have. What we expect to see is, of course, using the clustered index, the primary key column. But we can see here that there's an index scan on the ship ID index column. So this is a scan. This means that it took 92 milliseconds to run this query with 1 million orders. With 100 million orders, it's going to take 9,200 milliseconds, almost 10 seconds for getting a single order. There's no way users are going to accept that. They're going to be just really, really angry with us. So no, that does not work out. Just in desperation, we can also try the search on status and see what plan do we get here. We expect to use that filtered index, but it says clustered index. Oh, it's clustered index scan. Same problem again. So why does this happen? Well, the problem is this. Here we have parameters. Here we have the query. Now, what SQL Server does not know, but it doesn't know that, is maybe there could be some statements in between doing something like this, because SQL Server just optimizes one statement at a time. It does not look at the entire code, because if there would be something like this that would change in the variables, that could completely turn the tables. So it must create a plan that it gives the correct result for any value of the parameters. It cannot make any direct assumptions, and therefore it cannot use seeks, it must use scans. So that is the problem. So we will have to try harder this, I'm not going to repeat what says on the slide, but I've just put it in there so you can see it for reference. So there's also this hint, optional recompile, that you can put at the end of the SQL statement, telling SQL Server, every time you run this statement, recompile this. Let's see if this can help things out. So this time, there's no with recompile here, but it says optional recompile down here. Go and integrate this guy. And then we'll run my tests again. And yeah, they seem to be fast. And the execution time, yeah, this one is really fast. It's actually -1 milliseconds. That's really fast. These things can happen in modern computers where clocks between cores are not always synchronized. So, but anyway, we can still thinking, would this be good in production? Well, again, let's try to check the query plans. So we're going to do that. And let's see now, we have clustered index, clustered index seek, exactly what we wanted. So now it's going down the clustered index, right way down to the key, which means that, well, we get the same, we will get the same performance in production as we get now. Well, okay, there will be a few more reads because the index tree is deeper, but we can ignore that. This is okay. And we can also verify this with the search on new orders. And let's see here. Is index seek yes and status X. That's the index and status. So yes. So we can see here now, this seems to work well. And why does this work so well? Well, so now because we're only optimizing this query, SQL Server can be a lot more aggressive. So let's say, for example, we take this search on new orders. Well, SQL Server says, okay, already compile time, order ID is null. Well, it's a constant. So I can just take this out of the equation. And same goes for all the other conditions. Can just throw them away. And well, this one, true. And it knows that the value is n. So now SQL Server is actually working with the same thing as we have submitted this exact query. And therefore it can use the filtered index and it's not being confused by all the other conditions. So now we can get different plans for different search conditions. But wait, there is more. So down here, we have two searches with the same profile, a custom ID and a date interval. But still, they're quite different because this guy, ERN to C, this is by far our top customer in Northgale. He has 10% of the orders. Baldassar, on the other hand, is just an occasional customer, one single order. This one is a date interval is just one single day. This one is a full year. And I should say there is no combined index on customer ID and from an order date. There's only one index on one index on the customer ID and one on the date column. So let's look at the plans here. And first one here, which index is going to use? Well, the answer is it's actually using both indexes for this one. It's using, you can see there's index seek and the index seek, and there's a hash match between those two. It's not very common to see SQL Server doing this, but occasionally it can make these plans. But if we look at the other one, we can see now there's only index seek. This one down here is a key lookup. So this is just the loop joins. Now it's only using the index on the custom ID because it doesn't really make, because we now have the full year. And I think in total, Northgate has orders for 6 years. So that's we're actually addressing about 1/6 of the data. And that's just way too much for an index seek with the key lookup. So this is also very interesting. Not only do we get different plans depending on the profile, but also on the values. So this is the key to success, because since only the SQL statement is recompile, all variables can be handled as constants. And to get good performance when you do these searches with static SQL, you always need this hint. There are a few exceptions. I will cover one quite briefly in this session. If I do the longer version, there's another case which is a little more special that I also cover. But basically, optional recompile is what you need when you're using this pattern. Now you may say to yourself, well, wait a minute, that cache is there for a reason, so it must be expensive to do all these compilations. Well, as they say, it depends. Well, I mean, users may not be very busy. You may only have a few searches per minute and the 50 milliseconds in compile time. Of course, that's not a problem. Not the least if you manage to slash down the total execution time. But now let's say you're using that procedure static search 4 to look up orders by order ID 100 times a second. Your CPU will go up in flames. That's just going to be really, really bad. So one way you can address this, if you have this situation, of course, is to do specific branches for the frequent searches. So you have, if already is not null, well, then you have already equals already without the null condition, and then but you have all the other conditions as far as they are applicable, and you don't have optional recompile. Down here, you don't have the condition on already, but you have all the other conditions, and you have optional recompile. So here you get a cache plan, and here you get compilation every time. Now, obviously, this means that the code is more difficult to maintain, and you can do, well, 2, maybe 3 branches, but hardly more, so it quickly gets out of hand. But I like to point out this, though. Let's say that you only have 3 search conditions that are indexed, and even more, you are actually forcing the users to pick one of these. Well, if you have that kind of situation, it might be viable. Overall, I should also say this, that if you don't have an index because you have a fairly small data set, then you don't even need optional recompile because it will have to be a scan anyway. But most of the time, when you do this, you have indexes in all search columns, or most of them. So you want the correct index to be used. But normally, though, if you have a high call frequency, if that is concerned, well, dynamic SQL will be your friend for reasons that I will return to later on. So far, we have looked at scalar search conditions, one customer, one city, etc. But sometimes users want to be able to search on a list of values. So let's add employees to the mix, for example, and they want to search for, well, 1 or more employees. And one way to handle this, of passing this parameter, very popular, is to pass a comma-separated list. So here's static, well, I'm outlining here static search 5. So that's an employee string, which is an nvacr max, defaults to null. And then I have this condition, employee ID. So I have a table valued function that unpacks the comma-separated list into table format. If you have never seen any of these before, I got an article on my website, a fairly short one, called Arrays a List and SQL Server. That shows the basic of doing this, and that also points to a longer one, which has just too many methods to do this. Anyway, so the whole thing is this: if this one is null, we're not going to run this query, and we have optional recompile to sort this out. Now, my preference, though, is to use a table value parameter because, well, we are on a database, so why not use tables? So we can pass a table value, and it's, again, it's a table value. We have to define a table type to do this, and it has to be read-only. Now, if you do this, you do need one extra step. You need to first inspect the table variable and save the result. Is there any data in it in a variable? And then use that variable in the actual query. And the reason for this, if you would put this exist down here, SQL Server would not handle the table variable as a constant. It will still go and check it at runtime. And then the plan will not be the optimal one. So we need this extra step. Now, so far, this is the logic of doing multi-value parameters. However, performance is a little problematic here because the optimizer knows less. Now, if we have a TVP, well, the optimizer knows how many rows there are on the TVP. But that's all. It doesn't know which employees. And that's perfectly all right if all employees has about the same number of orders, because that's all SQL Server needs to know. But let's say that we have some employees, they sell screws and bolts, and they have tons of orders. Other employees, they say Porsches and Lamborghinis, and they have 2 or 3 orders all through the years. And depending on which employee we search, the user select in combination with other conditions, we maybe should use that index on employee ID, or maybe we should use another index. But the optimizer doesn't know this. So if there is a skew, we could get a problem. Now, if we have a comma-separated list, now this is where things get really complicated, but that's not my fault. That is Microsoft's. So the good news first. So if you have a user-written, yes, multi-statement t-sql function, and you are SQL 2017 or later. And in this case, what the optimizer will do is first run that UDF and see, okay, it returns 3 rows, and use that to optimize the rest of the query. It's known as interleaved execution. Now, this only applies, though, if you're doing a pure select, returning the data correctly. If you take the result and insert that to a temp table or do an update, etc. No, it will not do this anymore. It will make a blind guess of 100 rows. Yes, which in many cases will be way too much, because typically users will only enter, let's say, 2, 3, or 1, 2, 3, 4 employees or something like that. Very rarely 100. And if you then do something else, XML, CLR, or older versions, it will also be a blind guess. And that includes if you use the built-in function called string split. And with the case of string split, it will be 50, no matter which version you're of. And if you're well, this blind guess of 100 applies down to SQL 2014. On earlier versions, it was 1 for a UDF, which is a better guess. And if you use XML and CLR, well, the blind guesses are different, but always way too many. Thankfully, there is a way to deal with all this, both with the skew and all the incorrect estimates for CSV. You take the data and bounce it into a temp table, because a temp table has distribution statistics. So now SQL Server can know which employees there are in the set, and also has got the correct cardinality. But there's still one catch though. You need to do an explicit update statistics on the temp table. Because if you don't do that, you could be running with the statistics from the previous execution of the procedure. Yes, this sounds really, really weird, but it has to do with the fact that SQL Server caches the definitions of temp tables, including the statistics. Now, down here is a demo that I'm not going to run because, frankly, it takes a couple of minutes to run and it doesn't give that much value, in my opinion. But if you download the whole thing, you're welcome to try this on your own. And what you should look at, there are up to five different functions called static search 5, with different using a temp table, CSV, etc. And what you should look at is the estimates on the final operator. The execution time, etc., is not going to be drastically different, but the estimates, and we can compare the actual values to the runtime values and see how good they are. And you will find that they're better when you use a temp table. Now let's move over to dynamic SQL. And let me say this from the beginning. Then searches with dynamic SQL incurs a higher level of difficulty. Not the least because it requires more discipline from the programmer. I've seen so many posts from in the forums from users that have made something in dynamic SQL and, oh, why doesn't this work? And you can't even read the code. It's completely unstructured. It's a complete mess. I mean, it's kind of write-only code. And you can easily end up in that way if you don't have a discipline when you write your dynamic SQL. Also, dynamic SQL requires more testing. That may not register right away, but I will return and explain that later on when I run the demo. Another thing to consider is permissions. So if you run everything with static SQL, well, users only need to have permissions to run the stored procedure because of something known as ownership chaining. But if you use dynamic SQL, ownership chaining does not apply. So therefore, you must grant users permissions on the select permissions on the table as well. Now, this is not a complete showstopper because there are ways around that. You can use certificate signing, or you can use execute as. This is something I discuss in great detail in an article on my website called Packaging Permissions in Stored Procedures. As it happens, also, I will present on this topic on the GroupBy conference next week on Wednesday. GroupBy is a virtual conference. It's just free. You can www.groupby.org, so you can go there and register if you want to catch this. And all this said, dynamic SQL gives you a lot more flexibility, and that we're going to see some examples of that. But first of all, let's look at the core for all searches with dynamic SQL is this procedure called spexecute-sql. I would guess some of you, most of you, maybe all of you, have already seen this one, but it's so important I like to cover that and explain it. So what you can say what it does is that it creates a nameless stored procedure and saves it into cache, not to disk, but into cache, and then executes it all in one go. And next time it will look up that procedure in the cache. Now you might think, but if it doesn't have a name, how can it find it in the cache? Well, so it's identified by a hash computed of the query text as is. So there is no normalizing of spacing up or lower, comments, etc. before computing this hash. This means add a single space and it's a new hash, a new cache entry, and potentially a new plan. Now spexecute-sql takes a couple of parameters, and the first one is, well, the SQL string to execute. Beware, it must be nvarchar. Normally, SQL Server lets you get away with mixing nvarchar and varchar and nvarchar. Forth and back, you don't get in errors. You might get poor performance, but you don't get in errors. But every once in a while, SQL Server thinks, no, let's see if the user is awake. So this is such a case. Here you must pass nvarchar. Sometimes I'm just thinking that SQL Server is designed for maximum confusion. Yeah. Anyway, so the second parameter then is the parameter list. It also has to be nvarchar. And that parameter list, how does it look like? Well, it has exactly the syntax of a parameter list for a stored procedure. And finally, then the remaining parameters are simply the parameters for the value in the parameter list you pass. Because remember what it does, it creates the stored procedure, you define the parameters, and then you run it all at once. So let's have a look at the practical example. So first of all, I got two variables for my SQL statement. One for the SQL and one for the parameters. Now this one at SQL, always make this one nvarchar max, because you never know, all of a sudden you run out of characters. You run over whatever limit you set, and then you get your string truncated and you get confused. I remember a particular funny case. That user had declared his SQL variable as 50 characters, and it didn't work because his SQL string was 51 characters. The params, I usually go for nvarchar 4000. If you need max here, I think you have too many parameters. Then these two variables are just local for this example. So at count and at count 2. And here I got an SQL string, select at count equals count star from debug.orders, where custom ID equals at cust ID. And then I define my parameters. I got the cust ID and I got the count, which is an output parameter. Now, for dynamic searches specifically, you rarely need output parameters, but I throw that in because, well, I like to show you that it is just the syntax of the same syntax for a stored procedure. So here's an example call. I call spsql, my SQL statement, my parameter list, one of the customers in Northgale, and I get back the count. And look, notice here that this variable and this variable, they are not the same. They have the same name, but they are different scopes because this is a different stored procedure. And here, well, this is a different version. I'm actually define the parameter list inside the call. I tend to do this if I only have, let's say, 2-3 parameters. But if I have more, I tend to use a variable because then I can make the code clearer, I think. And also, I can use name parameters here if I feel like for some reason. And also, the actual variable here is called at count 2 rather than at count. So yes, they can be different. So let's run this, and yeah, I get back some counts. Now, let's look at dynamic search 1, the first procedure for dynamic search. Now, you might recall that for static search 1, I basically only needed one single slide, but I will need a couple of slides for this one. And I will start making just a quick run through of this procedure, just very quick, and then I will cover it more in slides. So here I got the parameter list, and you can see I got both the employee string and the employee table. I also got the debug parameter that I will return to, so my variables and my select list, and then I go on and add conditions. I can order by clause, that's where I use the debug, the parameter list, and I finally make the call. Now, I'm going to take this in a lot more details on the slide. So first of all, this is the first part. I got here the SQL variable, the parameter list, and the NL variable that I will come back to in a second. And I've shortened out the select list, and here are the join conditions. Now, a few things here to call out. First of all, this DBO dot. You may not have noticed that in my stored procedure, I did not say DBO dot, because I'm thinking that as long as everything is in the DBO schema, adding DBO dot before every table is just 4-character noise. But when we use dynamic SQL, it's different because users could have different default schemas. So let's say we have the users Jack and Jill, and Jack has the default schema Jack, and Jill has the default schema Jill. Now, this means that if there would be a Jack.orders, well, then, and it does only say from orders. This means that, oh, if there is a Jack.orders, SQL Server should use that table rather than using DBO.orders. So therefore, if it only says from orders, SQL Server puts this in the cache, it's thinking, oh, at any second that it could appear a table Jack.orders, I need to consider this. Very, very unlikely, but SQL Server, yeah, thinks, yes, this could happen. So therefore, Jack has a cache entry of its own, and Jill has her cache on its own. Let's now imagine there are 3,000 users, each with their own default schema defined for their user. Well, then you get 3,000 cache entries, which is very bad because you are wasting memory. That's not what you want. It's known as cache littering. Now, in practice, users most often have DBO as the default schema, and this is not an issue. But don't rely on that because, well, the DBA might have set up the database in a funny way. Maybe he's an old file because way back then, in SQL 2000 and earlier, it was always the case that you had a default schema that was the same as your username because schema and owner was the same thing. Yes, that is true. Now, then we have this condition here where 1 equals 1. So this is just one simple thing. So when we go on and add conditions, we don't have to think about, is that already where? Well, and the optimizer is smart enough to understand that, oh, this 1 equals 1. I can just throw this away. doesn't matter. And finally here we got this at NL, which stands for new line. So this is a character return line feed, and the purpose is to make the dynamic SQL, well, decently easy to read, because every once in a while your dynamic SQL is going to error out and you have to look at it. And of course it's easier to understand code which looks nicely formatted, at least decently nicely formatted. So then we go on adding conditions. I'm just showing a few examples here. This is quite repetitive code. If already is not null, well, NSQL plus equal, and already equals at already plus NL, and so on. Already equal from name, custom name like custom plus %. A few things to call out though. First of all, this operator plus equal added in SQL 2008. So if you are still in 2005, you can't use it, sorry, but then you need to upgrade anyway. But it makes the code a little shorter. This is a very important thing. This is a matter about discipline. Always put a space after the opening quote so you don't have strings running into each other. This is really one of these things about discipline. You write in this very repetitive codes, you need discipline to do it always right. And also this thing about the NL, adding a new line after each condition. So I don't get all conditions all one single long line, and the SQL Server tells me there is an error on line 4, yes, and that is that very long line. Yep, that's why I want them to have a new line so it's easy to read, and also if there is an error I can tell on which line it is. And finally here, well, since I need to include the string, I need to double the single quote inside the string literal. That it's how it works in SQL. And then we have the multi-value parameters. And so if the employee table, I'm going to just check if there is data, I'm going to add that condition. Same thing for the employee string. If that one is not null, I'm going to add that condition. Now watch out. It has to be DBO on the table valued function as well. Because if there is no DBO here, well, then we go back to the same thing. SQL Server is thinking, oh, at any second that could appear a table jack.int to TBL. So I can't have the same query plan for Jack and Jill. Of course, completely silly, that is never going to happen. But you know, these computers, they are just sort of, yeah, they always want to cover their asses, etc., etc. This is very embarrassing, actually. So I had this up on my website for quite a few years until I made this presentation without the DBO in the scripts on the website. Yes, that's embarrassing. Now, some people might be thinking, well, wait a minute, do we really do this? Can't we do this instead? Don't even think about this. Now, please don't tell me that you thought about this. No, don't do this. And why this is bad, we're going to come back to that in a couple of slides. Then we have this debug parameter. This is so important. When you work with dynamic SQL, you should always have this debug parameter. Defaults to 0, but then you have this statement: if debug equals 1, print SQL. So if you get an error or you get the wrong results, you can see what you have created, because if you don't, you are in a completely dark room trying to find out, oh, what's wrong here? You really need to see these. Always, always, always. Zawsze, toujours, immer. Just pick your language. Always need this. And then finally, we're going to go and make the call. And this is the simplest part. We just set up the parameter list. We don't here we don't have to think about, did that really the user actually pass a status parameter? We don't have to do that. There are some languages that were bigger. Well, you have a status parameter, but you don't use it. SQL is not that sophisticated. But one important thing though, yes, we need to use the DBO for the table type as well, or else again, yes, SQL Server might think, oh, that could be a jack.int TBL type that could appear in a second. And this is really embarrassing. I had this DBO was missing from this presentation up until last year when I realized I had it missing. So embarrassing. So anyway, let's now go look at this procedure in a little more detail, and particularly run some tests. So I'm going to go in. First of all, we might notice here that I am on line 4. And I'm going to scroll down to the end. And now I'm on line 95. So that's 90 lines of code. That's quite a lot more than we had for static SQL. Remember what I talked about, that dynamic SQL starts with higher complexity. So anyway, let's run this and search for single already and look at the, well, the results is good and the output. Well, once we come this far, this is simple. I'm not even going to look at the query plan because this is going to use the clustered index. No discussion. That's just plain simple query. So once we come this far, it was quite simple. Now here's another search. We can have, well, search on product ID and our customers. We get a combination of parameters. Maybe not equally apparent which index is going to use, but we can't really do much better than this, I think. And here we have one with a composite list and a region. Yep, this also looks quite good. Well, let's run one more search, but hey, this debug parameter is for web. So this is a search for a city and product ID, and must declare the scalar variable at city. Oh, maybe debug is not only for webs. Maybe we need to investigate what is going on here. Yes, it says at city. What's, well, how did this happen? Let's see and go look at the code. Let's see, we can look at the search for city. No, it's the P. Oh, some joker has commented out the new line. Uh-oh. And what about the product? Oh, look here. The space is missing. That discipline thing, lack of discipline. So remember what I talked about, requires more testing. So here we have this devilish situation. It's only this particular combination that fails. Had we also entered region, things would have worked, because here is a opening space to repair for the new line, and here's a new line to repair for the missing space. So it's only this combination that fails. This is kind of a devilish thing. If you have lots of combinations, and that must be one single combination of condition that fails. And that doesn't happen with static SQL. Now, this is the sad story. Not the people that do it this way. Some people, they do this instead. They just inline the value into the query string. ORD is not null, and ORD equals, then convert varchar ORD. City is not null, well then city, 3 single quotes plus city, 4 single quotes. I mean, this is not easy. This is just make the code more bulky, difficult to read, etc. But of course, this one looks simple. This was the one I told you not to do. It looks plain and simple, but this is bad. And we're going to look at the procedure called dynamic search. Bad, because, well, it's bad. So here is now, it's no parameter, because everything's being inline down here. And I did not include the employee table here, but yeah, we got this one, the employee string, the debug. And I'm not even using spsql. I'm using exec parentheses at SQL, an older form of dynamic SQL. Yes, it's the spsql. This one was introduced in 6.0. spsql was introduced in SQL 7, for those who are really interested in historics. But I find this to be shorter when I don't have any parameters. I tend to use that, but maybe because I'm an old fart. Anyway, let's now look at this and run dynamic search 1. And dynamic search bad for a search on the single ORD ID. And yes, we get the same results. And this one here, well, it says at ORD ID. This one says at 11,000. Now imagine now what's going to happen if we now search for order 11,001 or 11,002. Well, it will not be the same string. So it will be a different hash value, and therefore a different cache entry, most likely with the same query plan. So we're just going to litter the cache when we do this, because every search already, everyone's going to produce a new plan saved into the cache. Then we have got this search. I'm going to search for customers in the beautiful city of Lviv in Ukraine, and Lviv here is here being spelled in Ukrainian, and who have ordered stout. And oh, here's something wrong with the results. We don't get back in results from dynamic search bad. So why? Well, here it says at city. Here it says Lviv. But think of this. There is no N here. So this is an N varchar literal. Now, my collation is a Finnish Swedish collations, and there are no Cyrillic characters in that collation. So SQL Server then is going to just replace these characters with fallback characters. And because there is nothing to fall back on, it's going to use the generic fallback character, which is a question mark. So that's why you see get this. And of course, then it's not going to work. You will not get back anything. This is because that the programmer who wrote this should have put in an N here, or maybe here. I don't even really know, actually. It's just also really confusing with all these quotes. Just makes things more difficult. Now, here's another search. I want to find orders from customers who are located in the same city as this customer, Rexy. So we're going to just look up that city and then run a search for it. And I get incorrect syntax near Emilia. Unclosed quotation mark after the character string, order by order ID. This is because this customer is located in Italy, in the city of Reggio Emilia, and there's a single quote in the name. Something, again, which the programmer who wrote this did not consider that could happen. And then we got this one, which looks like the employee string, which looks like just complete garbage. 0%, exec command shell, DRC colon, select star from, select one as already, SO, and 2 hyphens. You're saying to yourself, this is just going to explode big time, just like what it deserves. No, it did not explode. So when empty results it, my contents of my C drive. Huh, I'm glad it didn't say format SQL. And then an order, single order result. So what happened here? Well, so here we got a full query. And employee ID in percent. That was we had that 0% there. And then we got this XP command shell. And then we have got this funny select, which is there to neutralize this order by order ID. And these 2 hyphens serves to get rid of this, to neutralize this parenthesis that was intended to be up here. Now you might say to yourself, oh, yeah, okay, this was kind of cute, but let's go on with the real material. I mean, it's lunchtime, I'm hungry. No, so this is maybe the most important thing in this entire session. So what you have witnessed here now is an example of SQL injection, which is a very serious security issue. When you hear of sites being hacked, it's very, very common that it was an SQL injection issue. There was some way, either in the application or they were, or in the procedure, they were building an SQL string by inlining values. And you might say to yourself, yeah, but it's going to take forever for an intruder to find this. No. These people, I mean, they're making big money from this, either by planting ransomware or stealing data or infecting your site and use that as a stepping stone for a distributed denial of service attack against some other site. So they got good tools on their hand, and they probably will find this one in minutes, if not faster. So yes, this is bad, and the worst of the whole thing is that it opens for SQL injection. That is what you need to avoid, but there are also the other issues about performance. So let's now look at the cache and compilation. And look at, so if we run static search for and search for 3 order IDs, well, we will get 3 compilations and 1 cache entry, but it's not really used, but there will be cache entry. If we use dynamic search 1 and search for 3 order IDs, we get 1 compilation, we get 1 cache entry, and that's why searches for dynamic SQL is better when we have a high call frequency, because depending for each combination of parameters, we can reuse the query plan. And with dynamic search bad, well, we get the worst of both worlds, 3 compilations and 3 cache entries. Cache littering, wasting memory, wasting cycles, everything. Not good at all. Here's another thing to look at this. With option recompile, on the left hand, well, we get compilation every time. With dynamic SQL with parameters, we get a cache span per combination of parameters, because it will then be the same query string. This means that with option recompile, we will compile a lot more than it's actually required, because every once in a while we will generate the same plan. And with dynamic SQL, well, we will have a lot less compiling. But it cuts both ways, because with option recompile, well, then we have a good chance that the plan will always fit the current parameters. But with dynamic SQL with parameters, we can get an issue with parameter sniffing. Excuse me, I'm going to get some water. So let's have a look at this. So I've got a script here, and it has 3 different searches, and for all these searches, I'm going to use static search for, dynamic search 1, and dynamic search bad. And the first search is searching for this big wish customer, ERN2C, for 1 single day. The next search is this only 1 order customer, $R, and it's a full year. And the last search is I'm searching for status E or error orders. And I'm going to run all of these searches and take an execution time all at once. And let's see what result we get. And yep, I got the result I wanted. Now, if we look at this search, it may seem that dynamic search bad is a lot faster than the other 2. No, that's not the case. It's a mirage. And the explanation is here, because a management studio only had to spend time on rendering these 2 results, not the third one. And when you have to keep this in account when you're doing things like this, particularly if you're running very fast queries, SMS can affect the results. But here it's very clear that this one is a lot slower than the other 2. These ones are just instant or even negative. And the same thing here. And why is this the case? Well, let's go and look at some query plans. So let's try this Bolasar first with static search 4. And we have already looked at this query plan, but we might want to repeat it. And we see here we got an index seek on the customer ID in the index. That's the only index it uses. Now, if we look at dynamic search 4, dynamic search 1. So which plan is that one using? Well, it uses an index seek on both the already index and the customer index. And this hash match, you might notice here that there is now a warning sign here, meaning that the hash operator spills to disk. So why is it? And you can see here that's a big over. The estimated number of rows is below 2,000. The actual number of rows is just 100 times more. And why does this happen? Well, because it's a cached plan. And this plan was originally created for this search. So that's why we got this parameter sniffing issue. Now, if we look at the search for error orders, well, static search 4, it's using an index seek on the status column, but dynamic search 1, it's, let's see, yeah, it's a parallel plan. And let's go to the right, and it uses a clustered index scan. It's not using the index on status. So why is that? Well, because it's a cached plan. Wait. We haven't run any searches on the status column yet with dynamic search 1. So how could that be a cached plan? Yes, that's true, but it's still a cached plan, meaning that it must be correct for any possible values of status. So it has also to get the right results, even if we pass this value, which is of course lunacy because that's 99% of the orders. But nevertheless, SQL Server just thinks that, oh no, that could happen, I don't know. So it can't use the filtered index because it has to be correct with any other input value. So let's now look at how we can address these things if we are working with dynamic SQL. First of all, option recompile is still possible. If we know that this particular combination is difficult and we know that it's not particularly common, then of course we can solve this with option recompile, or particularly common when, let's say if there's being done once a minute, that's okay. But if it's being done 100 times a second, it's not okay to use option recompile. Now, if we think that I don't want to use option recompile because I got a very busy system, here are some tricks you can try. So you can look, if you have this combination of from date and to date, you're going to look at the date interval and say, okay, add different comments. This might seem just creepy. What I'm doing this for, because it's not going to affect the logic of the query, but it will affect the query string. So depending on the therefore, you will get different hashes and you will get different cache entries and with some luck, different query plans. Now, as you might understand, this is not exactly easy to do. You have to have some understanding of your data, and it will be less granular than using option recompile. So it could be that for some of these cases, you might still not get the best plan, but it may still be a plan that is good enough. But yes, you can still have problems. Here is a little more, that creates more plan, and it's a different way of doing this. I'm again taking the length of the number of days of the interval, and then if it's up to 7 days, I'm going to add a comment that, okay, it's 1, 2, 3, 4, 6 days. So for up to 7 days, there will be one plan for 1 day, for 2 days, etc. Then up to 35, I'm going to do it per weeks, and then beyond that for months. So this will result in more query plans, and some of these plans will, more cache entries. And some of these cache entries will absolutely have the same plan, but you will have less risk for poor plan choices. And I like to point out that this very much shows you the power of dynamic SQL. Once you started doing dynamic SQL, this is kind of quite easy to do. It's just you're just building strengths. Another situation you might have is that you might have a very big skew. So let's say that it's not true for Northgate, but it could be the case that 60% of all customers, they are in London. So then you don't want a plan with a customer, or if you have a customer from London, you're searching for that, or you're searching for the customers from London, you don't want the same plan as if the city had been Paris. So the one way to deal with this is simply, okay, if it's London, I'm going to hard code London into my query, else I'm going to use the city. Also, if you have this status column, you might say that there's only 4 values, and basically searching for new orders, error orders, processed orders and the complete orders, they are really 4 different searches. So in that case, because there are so few values and they're skewed, you simply inline them into the query. And I'm using the quote name function and passing a single quote just in case for some reason, if the UI would or the caller would pass a single quote, I will not get SQL injection. I will not get a syntax error. So this quote name function is quite handy. But this inlining you should only do on its very special cases. Don't do this on a general basis because you will litter the cache. We have already talked about that. So it's a very, very special case to do this. And also here's another a way to deal with a filtered index. We're simply saying, okay, if the status is not C, well, then we're going to add the filter condition to the query, because that will have an effect, as you're going to see in a second when we look at this demo. So dynamic search 2. And now I got my, I don't have the employees things here. I got my dative parameter. And what I'm going to do here is, here's the status thing. So I'm going to add, if it's not C, I'm going to add the condition, oh, status is different from C. Here I'm doing the thing, I'm adding the comments, the first simpler version. And here I'm doing, well, the from bit to see where the city. And if it's London, I'm going to add London. And else I'm going to add the city. And that's about it. I didn't get everything I had in these slides into this script. So let's try the search on error orders now with the query plan. Let's first look at the output. You see, and status equals at status and O status is not C. And now it's using an index seek on the status column. Great. And here we have these 2 searches again. The customer ID and date interval. And we can see here, it says a single day, more than a month, but apart from that, it's exactly the same query text. But when we look at the plans, this one is using 2 index seek and a hash match. This one is using index seek and there's the key lookup. So we did get different plans. And finally here we got to search on cities. So we're going to search for, well, customers who have ordered product 802, both from London and from Berlin. And let's see here. First of all, look at the query text. This one says London. This one just says at city. And execution plan, well, let's see, there's nested loops, clustered index, and there's a sort. We did get different plans. Or I should say, as I mentioned, London, I think, is the most common city in this database, but it's not 60%. So it's not unlikely that we would get the same plan. So then there might be more things we want to do with our searches. So let's, in this Northgate database, there are actually 2 sets of order tables. That is also historic tables. So, and if the user or the caller passes at historic, we're going to search these tables. And with static SQL, well, we can do this with the union all. So here we got the join on orders and order details, and here we got the join on historic order details. And we got a filter here on historic, and on recompile, we'll make sure that when we run the query, only one of these pairs will be in the plan. The code gets a little more bulky, but yeah, it's dealable, at least so far, with only 2 tables. Now with dynamic SQL, it's slightly more. The code is at least shorter because we can only just say for every table case historic, I only have to specify which strings I put in. I could, this particular case, maybe even have, I only had historic if I want to make it really creepy. But anyway, so this is slightly shorter. But this is the way. You should not pass the table names, but rather have some flag to control this. Then you also might want to have, the user may also want to be able to control the sort order. And you might think, well, okay, if it's dynamic SQL, I can just say order by plus sort column. That's great. But then you have a problem because, or 2 problems. First of all, that opens for SQL injection. I don't think, oh, I'm writing the UI, so I got full control over that. Hey, someone might then 3 years from now get the idea of slapping a web UI on that store procedure and pass that sort column in the URL. All open for SQL injection. Now, so you need to decode the sort column. So if you were doing case here, well, if it's already, well, already. This also has the advantage if someone refactors the database and say, okay, we're going to call them all underscore ID with all lowercase, etc. Well, then you don't have to change the client because you have this mapping. And then if the users want descending or ascending, well, there's just adding a check on is descending. Do this. One important thing though is you need this else to produce some sort of a default, because if you don't have the else, well, then this case expression is going to return null, and nothing's going to work. You will get no results back. Not even your debug statement is going to work because it will print nothing. So either you have a default or something that produces an error. If you wanted to say, no, you really need to pass a sort column. Now, if we're going to do this in static SQL, well, we can still use case, but we have to think about data types now because now it's being done static. So keep this in mind that case returns a single data type. It's a static data type. I mean, it's not. So if you have one single case expression for all of these, well, it will be the data type of the type which has the highest precedence, which is the data type. So then if you're going to try to sort on customer name, you will get conversion errors all over the place. So that will not be fun. That's why we need these 3 case expressions. But Optical Recompile is going to sort this out. It will only pick one of them will be included at runtime. However, as it says down here, if we try to add a multi-column sort or ascending descending, yeah, then things doesn't go too well. So here's static search 7, which I've added, well, both historic and also the sort columns with the defaults of order ID and product ID. And this also is descending one and it's descending 2. So here I've got the historic thing to do that, what I showed before. And here's the order by clause starts, well, if it's descending 1, well, we have these 3 sort columns and then 1 for it's descending 1, etc. And it goes on and it goes on and it goes on and it goes on. And the order by clause is longer than the rest of the procedure. This is completely out of hand. So this is an example of where complexity with static SQL tends to just grow exponentially when you add things. Whereas with dynamic SQL just sort of goes linearly. Because if you might recall that case expression, if you want to add, well, add one more sort column, well, then you add just one more of these. And you can even make it sleeker because you can have that mapping into a table variable. There is actually a script included in the download called Dynamic Search 3, which shows this, but which I'm not going to show because of lack of time. So the last thing I'm going to discuss quite briefly is, so you want to have even more advanced stuff. Users want to be able to, well, group by aggregation, select columns, etc. Very dynamic searches. And I've seen customers that have done this, but I would say there is a limit for what you can do with dynamic SQL in this procedure as well. I mean, it's easy to build strings, but how would you express all that in a parameter list? Yes, you could pass an XML document, but how fun is that? Now, I think that if you want to do this dynamic, I think it might be a lot simpler to construct the SQL client side in a class with a very beautiful object-oriented interface. The only issue here is about the one thing about permissions, because now you have to grant select permissions on the tables because of course there's no way around that. But apart from that, I don't see the wrong of doing this, even if you generally are using stored procedures in your application. But if you're going to do it this dynamic, I think this is perfectly okay to do this because it's so much about building strings and the client is just a lot better at doing that. But there's one thing you should never do. Not start building some SQL syntax in your client and send that to a stored procedure where you do the rest, because now you get a very tight coupling between client and server and it's going to be a maintenance nightmare. Don't do that. Either do it all client side or all in the server. Now, there is a kind of part 2 of this presentation and particularly of the previous slide. On the Group by conference way back in May, my MVP colleague Eitan Bluin from Israel, he had a presentation, Dynamic Searches in t-sql, the ninja way. And his presentation starts where this presentation ends, you could say. Because he's doing all that stuff that I showed you, but he had made the framework out of that, and it's actually using stored procedures, but that's another story. But he has done the heavy work for you. Or you can go to his Git subsites to download his goods directly. So I only would like to make a quick conclusion before I end this. So we have looked at 2 ways of doing dynamic searches. We can use static SQL with Optical Recompile. That is good for the complex, simple cases, but as you add more different things, complexity sort of grows exponentially, so it gets difficult to maintain. Dynamic SQL, on the other hand, is just too much simple for the simpler cases where all you have is a bunch of conditions, but once you add things, it scales a lot better in complexity. What to use is a decision to make from case to case. I would say when in doubt, start with static SQL, but be prepared to switch to do dynamic. So that was all I had to say. My name is Erland Sommarskog. My email address, again, is sql@sommarskog.se. Feel free to drop me a line. And I'd also like to point out that slides and scripts are available at my website, sommarskog.se/present. And that also includes the scripts to build a database. And to do that, you need to run two scripts. First, this script to build Northwind, and then Northgale needs to have Northwind present to build Northgale. So that was all I had to say today. Thank you very much for listening. And any questions?
There are only comments as far as I can see. One is you can use char 39 in your code instead of the double single quote combination.
That's a good comment.
The rest of them are thank you for a good presentation, which I agree with. So, and it is kind of thorough, but that also doesn't leave much room for questions. So I think I've seen your presentation before in an auditorium at the Microsoft site in Kista years ago.
Yeah, it was in Swedish, and it was basically the same, but it hasn't changed a little bit since then.
Yeah, and I think it was one of the first times you were on kind of a road show with this presentation. So I think you did it on a couple of SQL Saturday, but it was fairly new.
I think actually that you actually saw my premiere as doing a presenter on the SQL Server Trade.
Yeah. All right. That's good.
I like to comment one thing there doing car 39. Yes, that's a good tip. And what I also tend to do, particularly when it gets really complicated, is I tend to define a variable which I typically call @sq, into which I put the single quotes to make it a little more compact. But yes, car 39 can also be a good thing to avoid this, because sometimes when you for example, we're going to build something with Open Query, you have this, it's just you see people with 8 single quotes in a row, it's just a complete nightmare.
Yeah, I mean, sometimes you do dynamic SQL in dynamic SQL because you after a while your mind will stop working, and at least for me, I have to refactor that code so that I don't have that nest level inside my own code at least.
Yeah. So I have another article on my website called The Curse and Blessing of Dynamic SQL, which it was the first one I wrote, and I've been rewritten a couple of times. And now came out a couple of years back, and now includes a style guide that try to give some tips just to avoid problems, how to write Dynamic SQL readable, easily maintainable, which things I learned through the years.
Yeah. Let's see, you said don't send direct SQL to SP, but in your multi-order by example, isn't it easier to handle this kind of order by loop in the UI code side?
So yes, many cases when you want sorting, you simply should sort in the UI. So you don't send an order by, that's a correct observation. It's often better to do the sorting in the UI and that don't do that in SQL Server. Particularly, you might return results back to the user, and the user says, no, I don't want to sort it this way. I want it sorted this way. And of course, then you don't want to rerun the query really, or you should not have to do that. So that's perfectly correct. It's often better to do the sorting in the UI and just return an unsorted result set.